record sharing screen. Was there any questions? Any questions about this push and pop? Hello, can you guys hear me?
Yeah, we can.
Yes. Okay. Yeah, so no questions. Good. Yeah, so now what we're going to do is we're going to look at this Python API for Z3. I don't have too much time, but I think I'll be able to do this. So let's look at this. So this is, like I said, two ways to use Z3. So one is this. Oh, there are many ways, but two ways that I'm going to talk about. One is this, and the other is this Python API. So the comments are clipping out of the screen. I'm not going to, I think I'm just going to say what the comments are, so you can read those later. Don't worry about that. Right. So first things first, how do you use Z3 in Python? You import Z3. And in general, when you're installing Z3, I think other people will be able to give a better thing about this because I've only installed it once, but I've heard that just using pip install is sort of the best way to go, at least on Linux and Mac. I'm on Windows, I'm not sure. If you have any issues, let me know. I can help you. So yeah, so the first thing you do is import Z3, and then the next thing you do is you create a solver, right? So everything that you're going to do, or let's say all the expressions that you're going to, assertions that you're going to add, all the pushing and popping and all of that is going to happen to a particular solver. The idea with this is basically you can have multiple solvers in your programs handling multiple sets of assertions for, say, two different paths that you want to look at simultaneously in some complicated algorithm that you're doing, right? So you can have multiple solvers, but basically you have to create one solver to access the add and like the assertion and the push pop and so on, check sat, get model and so on. All of those are tied to a particular solver. So if we look at this thing, all of these commands like check sat, push pop, get model, assert, all of them are tied to solvers, right? What is not tied to solvers are variables and expressions. So the way you declare variables, or let's say create variables, is this. You use these constructors. So Z3 has got multiple constructors for various variables of various types. So here I'm doing ints, right? And you can use the constructors to create variables. So notice two things here. So one is that I have a Python variable name and I have a Z3 variable name, right? So what this is going to do is that this constructor will create a Z3 variable with this name and return that, and then we're assigning that to this Python variable. So this X is a Python variable, and if you look at the type of X, it's going to be an integer expression. The expression basically has just a single Z3 variable, Z3 integer variable, and the name of the Z3 variable is A. And I know this is confusing, and in fact, I mean, in real life, you would probably make sure that X and A are sort of the same, like you would probably call these an X, Y, and Z as well, but I purposefully did this just to make the distinction clear that this refers to the name of the variable inside Z3 subsets. I'm sorry. This is Z3 variable
so
name.
it's not really the instantiation of X, right?
No, it's not an instantiation of like X, in fact, at all, because like X is just the Python name for this thing.
Yeah, it can take any value. Same as A.
Yeah. So for example, essentially, this is not an instantiation of A. This just basically says that X refers to the Z3 variable, which is named A, which ends of type int.
Okay, and what is the point of this?
So the point of
this
this
we can have multiple variables with the same variable name, is it?
Yeah, no. So
X.
Yeah, I mean, firstly, you can do that, but also, you see, from Z3's perspective, Z3 doesn't even know that you have this variable here, right? Z3 could, for all Z3 knows, you could put this into a list somewhere. You could have put this into a dict. Maybe you're calling this and then never even storing this, right?
So the API is not that intricately bound to
Python.
The Python libraries.
Yeah. So all this does is basically it'll look up its variable table, and it's going to, if a variable that is of type int with name A exists, it's going to return a reference to that. And if it does not exist, then it's going to create a new one and return a reference to that. Right? That's basically all these constructors do.
Okay, thanks.
Yeah. So similarly you can have Y and like I have two more variables, right? Okay, so I'm gonna do this. I'm just gonna, okay, sorry. Yeah, so I'm just gonna go ahead and run this type and slowly uncomment this thing. What happened? Oh, I'm sorry. I'm supposed to write it with Python. Yeah. It is clear. Yeah. So basically, it's just giving me some variables and so on. So notice that when we print this, print x and y, we're printing x and y over here, and it's actually telling me a and b, right? So whenever you print this expression, like the Z3 API is going to pre-print it and like automatically format it and so on for you, and it's going to use whatever internal Z3 names that you put for these variables, right? And one interesting thing, one important thing to note is that if I do something like say k, like I was saying, if I do k is equal to z3.int a, so I'm going to ask you this: is k and x the same thing?
Within Z3 they are.
Uh-huh.
So within Z3 they are the same variables. Right?
Yes. Within Z3 they're the same variable. So essentially, in some sense, the reference returned to this by this function and the reference returned by this function is the same, right? So both of them, what they're doing is they're going to say that, okay, I have a variable name, which is a, let me look up the variable table. In this case, when we're calling it, it didn't exist. So it created a new row for that and then returned a reference to that into X. And then when you're calling this here, okay, yeah, a does exist. So let me just return a reference to that. So X and K are going to basically refer to the same variable inside of Z3. Yeah. So I mean,
one question then, is it possible to maybe say increment X and automatically Z3 will interpret it as an increment for A?
Yeah, exactly.
So if I increment X, then it automatically increments K, is it?
Yeah, so in fact, when you say increment X, what you'll do is you'll create this expression which says that X is equal to X plus 1, let's say, right?
Yeah.
So or let's say that, or even this, like you're going to say that, say y is equal to X plus 1, right? So Z3 is going to internally convert that just into the expression B is equal to A plus 1, right? And then if you now try to check the value of K, then it's going to say that, okay, I'm actually looking at the value of A right now. So it's going to use that as a value itself. So if you set any, if you have any assertion that's going to restrict the value of X, what that means to Z3 is to restrict the value of A. Z3 doesn't even know that this variable exists. So if you say assert something like X is equal to 2, what Z3 sees that as is A is equal to 2. And we're going to see that, okay? So does that
got it. So you're saying that since the type of X is not an integer, first of all, you can't even do an increment to X within Python.
Right. So if you write the code, it basically under the hood, it converts into a Z3 expression.
Right.
Yeah. And then it will not be an increment, it will be some assertion, right? Because then for increment, you need things like SS and so on, but let's not go there.
So no, I'm trying to say, is it possible to write now X plus plus as a statement? No, right?
In Python? No. You can't. So
yeah, because X is not an integer. It's just an integer of Z3.
Yeah, I mean, okay. So if you write something like this, for example, X is equal to X plus 1, right?
That should give an error, right?
No, it will not give an error. What will happen is this initially on the left hand side will refer to the variable X, right? And then you're constructing an expression that is going to say that, okay, or the variable A, sorry. So you're constructing an expression that says A plus 1, and then you're assigning that expression to X as well, right? So let's try that. So let's say X equal to X plus 1, right? And let's see what happens. See, it says A plus 1, right? So it's not like, so since A are just symbolic variables, their values don't make, doesn't make sense to talk about the value of A before you've done a check set, or, unless you have some model with inside which you're talking about the value of A, right? So when you do X is equal to X plus 1, what you're saying is that, okay, I'm going to construct an expression that is going to have like X plus and 1. And that expression is going to basically be A plus 1. And then I'm assigning A plus 1 to X, right? Does this make sense?
So it kind of does some sort of substitution over the variables within Z3. So Now that x is equal to x plus 1, essentially x is assigned the value a plus 1 within Z3, but k still remains as a.
Yeah. So if I do this.
I see. Yeah, that was my question actually.
Okay. Yeah. So think of these variables like if you're coming from a C++ sort of a thing, and the best way to think of this is this pointers to expressions, right? I don't know if that actually helps, but
yeah, I just thought of it as a frame for a substitution. So x and y and z and k are just like the environment on the left hand side, and the expressions are their substitutions. So you can make changes to the variables themselves.
Yeah, that is also another way of thinking about it. But then remember that like then it's not like x, y, and z, and then just k is another like name for something in your frame. The frame is going to be all four of these, right?
Yeah, totally. Yeah.
Yeah. So okay. So is this? Yeah, go on.
Yeah, one thing, like what will happen that you have written Z3 int A, right? And what if you just write K equal to Z3 instead of int you write float A? Then what will happen?
Yeah, I mean, I don't know if Z3 has a, I don't think Z3 has a float.
Z3 needs to have a float type inside
Okay,
it,
maybe
right?
decimal or whatever.
No. So I'll tell you what there is. If I go to this thing, so I'm gonna
actually, can Z3 even handle a float logic?
Yeah.
Like
There's floating point logic in Z3. Yeah.
I see. Nice.
Wait. So where is this thing? Yeah. Okay. Sure. So this is the okay. I need to make this way bigger. Yeah, but this is basically this this thing. Let me search for float over here. This is the Z3 namespace reference. But if I remember correctly, it was something like float 32 or float 16, float 32, and so on.
Real. Sorry.
Oh, real. Right. Yeah, we can do real with this. Like so far, we haven't done.
Like you declare first A as an int and then declare it as real.
Oh, okay, that's what you mean. Okay, right. So let's try that. Right, and let's say so how do we check whether this A and that A is the same thing, right? So
I think
you said Z3 is strongly typed, right? I mean, it has internal type checker.
Yeah. So
there should be no model, right, in that case?
Yeah, I mean, so I don't know if internally, so it, there should not be any model in that case.
Remove that x equal to x plus 1 thing.
Yeah, sure.
Yeah, because that might work. And
now you maybe just assert x is equal to k and then check.
Yeah. Okay, no. Why am I saying assert? It's add. So yeah, this is the thing. This is the syntax for adding expressions in, and inside Python, just so that other people can like sort of catch up. The way you build expressions is just using your standard Python syntax. You don't need to do the infix thing. The Z3 API has overloaded this standard Python syntax, so you can just do this, and then you can do s.add whatever to add your expressions in. So here what's happening is we are taking the expression x is greater than y, storing it in this variable, and then adding it to this solver by s.add. So add is the Python equivalent for assert, right?
And there are additionally push and pops as well, right?
There is push and pop. Yeah. So there's s.push, there is s.pop. I'll show that. I think, right.
Let's finish this x is equal to k.
Yeah. And then we do. Okay, so check sat becomes check. Interesting.
That's interesting.
Yeah.
Sorry, I had one question. So I thought like the Python variable x is pointing to like the Z3 variable a, right? So what exactly does a plus 1 mean? Like, is it a variable or
it's an expression?
Like, okay, so
be double equal to.
Oh, right. Yeah. So you're saying something?
Yeah, no, I'm just saying, so like, are the x, y, z's like pointing to variables or expressions in Z3?
Expressions. So when I say that x points to this particular Z3 variable, like in some sense of just a single variable is an expression, right? So
I'm pretty sure you can even
Okay.
instantiate x with a plus 1 directly, right? Let's
Yeah,
say
yeah,
from
yeah.
an
You can do
important.
that. You can do this. This is completely legal.
Yeah.
In fact, you can just do s dot add and then just inside there you can just do this. Like just construct a huge expression using the constructors directly. If you're storing, say, instead of like if your style is going to be just store the Z3 names of the variables in strings, then in some sense that might make a lot of sense. I don't know, but like the same. Also, that makes a lot of sense if you're writing some sort of parser that parses something into Z3 expressions, let's say. I think. So yeah, let's do this now. Yeah, now it's inside. Okay. So yeah, I guess I was wrong. It's not strongly typed then.
Yeah, it seems like that.
Yes. All right. So I'll actually, I mean, I was sure that I read somewhere that it was strongly typed, but I'll actually do some more things and check what's happening exactly over here. Okay.
Sure.
Yeah. So, I mean, I'm saying that I'll do that later on. Right. Okay. Actually, before I delete this, any questions so far? So what's happening is, I think when you're saying Z3, that means A is real and A is int, what it means is that it's not strongly typed is that in some sense, you can have like, say, so one way I think, yes, intuitively to think about this is you can have like two copies of A with different types, and then you can build expressions with them, which is fairly confusing. But I don't know if that's what's happening or something else is happening, but yeah. But any questions regarding the syntax and s.add and what we're doing when we're doing this?
Can we just try it in the .smt2 file?
This one, this k is equal to 0.5 and so on?
Yes, I mean, naming the same variable and int and a copy called real.
Oh yeah, there I think it will probably, declare fun will probably give an error, but let's see. Fun, so let's just call it x int declare fun x. Oh, sorry. Yeah, real, and then let's just say assert equals. I mean, this will probably give an error, but let's see. Yeah, I mean, see, it's telling me in line 4, it's giving me the error. Yeah, so there's an ambiguous constant, more than one sort constant with the same sort. More than one constant with the same sort using qualified expressions. Right.
So there's a possibility for typecast, and if you don't mention, then it automatically typecasts if possible.
Yeah. I think it basically it is strongly typed, but it maintains multiple copies, multiple symbol tables for each sort is what's happening, right?
And then I guess it maintains some sort of like weak relation between the types.
Yeah.
Say that if it's an int, then it's also a real.
Yeah, to do some sort of typecasting when it's doing that. Yeah, so that is actually fairly interesting, because then like technically speaking, the SMT theories don't really need that. So it'll be interesting to see exactly how they define it. And like if you look at the SMT specification, it doesn't actually give you anything like this. Like the fact that there should be weak relations between them or something.
I haven't actually looked at the specification, but I think it's possible to define them in theories.
Yeah. I mean, it is definitely possible, because you'll have to just extend the definition of equality and various operators.
Yes.
Work with.
Yes, exactly.
I mean, it's easy. I think. At least I don't think it should be difficult. Yeah. So does this sort of?
I was thinking that we might discuss this type stuff later, because like it might be getting confusing for other people.
Yeah, that is a great idea, Harsh. Thanks. Sorry. So if you weren't able to follow this, but are you at least focused? I'll give you the intuitive idea of what's happening. Think of this. It's this way. Whenever you're doing something like this, there is like two separate kinds of, like in C or C++, right? You'll sort of have two separate variables referring to one referring to an int, one referring to a real, right? So this operates like two variables, and whenever the parser can't decide which variable you're talking about, it's going to complain, right? So at least in that intuitive picture is what's going on so far clear?
Yeah.
Or is there even if there's a question in some previous level in terms of what's going on in this Python syntax, is the Python syntax uncommented stuff so far, is this clear?
Yes.
Yeah. And Libby, is everything clear? I've not heard from you, so I'm just wondering. Oh, okay.
I think Anleeb is not here.
Okay. I think she had some internet issues. Okay. Sad. All right. So Chandra, it's clear, right? Or is any question asked?
Yes.
Okay. Yeah. So this is basically, I commented this out, but I'm still screen sharing, right?
Yep.
Okay. Zoom is being really weird today. But yeah, basically I had commented this out, but you have seen all of the things I'm talking about over here. Okay, now let's talk about getting the model in Python, because that is also somewhat can be a little bit weird. Pushing and popping is exactly as it works, like there's a stack and so on. Oh, I'm editing the same copy in two places. Let's not do that. Right. So getting the model, you do the basic syntax is just this. You do m is equal to s.get model and print m. So before that, let's just look at what we have added so far. We have added just x is greater than y, which means a is greater than b, right? We have added that in. We are just going to print s and s.check. Okay. So let's just run it so far and let's see what happens. Oh, wait. I think we need to delete these guys. Yeah. So firstly, so far, like line number 19 is the second line over here. So far, so good. Then we're adding this thing here and we're saying, okay, what is the expression? This expression is this one. So that is also fine. Then note over here, we're just printing out the solver. So when you print out the solver, what the API will do is it'll give you a list of all of the assertions that you've added to the solver. So it's giving me a list of a single assertion so far that we've added. And this is a greater than b. We're doing s.check. This thing returns something called some weird type, but basically it has got two constant values, z3.sat and z3.unsat. And you can use that to check whether it was sat or unsat. And printing that will just give you a sat or an unsat as a string. Now what we come to is get model, where we do s.model. And what this will give you is this will give you something like a model which you can print. So when you print it, it just is going to be a list of assignments, right? So notice a few things. We had three variables here, A, B, C, right? Okay, let's delete the K thing here. But we have three variables A, B, C inside, like defined. But this model doesn't actually talk about C at all, right? Because I mean, so far, all of the constraints that we have added, C is really irrelevant, right? So in some sense, you can ignore C in your model. So the model that has been returned is not going to actually have an assignment for C. So in this case, that makes sense because we have not even used C in the constraints. But if somehow Z3 is able to simplify the constraints that you've sent to eliminate a variable, there won't be an assertion for that variable in the model. Okay, so just a heads up, I'll just go for 5 more minutes. Don't worry, I'm not going to take too much time. I know there are classes later. That's okay, right? Everyone?
Yeah.
Okay. Yeah. So basically, Z3 is not going to have an assertion for the variables that it manages to, in some sense, eliminate via some simplification. So in this case, it was just some, like the elimination of C was trivial, but basically there is no value of C in this model, right? So this becomes important when you want to actually get the value of the model as an integer inside of a program. So let's look at how you would do that. So let's uncomment this part, right? So you can sort of, the syntax for doing that is basically sort of treat the model as a list of, or as a dict where your keys are going to be the references to your Z3 variables, right? So you can use a reference to a Z3 variable, or I can use say Z3.int a here, for example. you can use that, and then when you use that to index your model, you'll get the value of that, right? So let's see what that is, right? Yeah, so we are getting the model, and then we're getting the value of the model, the eval, and the value is 1. It prints out as 1 at least. But if you look at the type of whatever this thing is returning, this indexing is returning, this is some Z3 type, right? So what this will do is basically, this will this allows you to treat your model as a dict from Z3 variable references to Z3 constants. So this returns a Z3 constant of type int with value 1, right? So you can't directly use that in your Python code, because if I now say print eval, let's say eval plus 1 something, yeah, see, it prints out 1 plus 1. It doesn't print out 2. It's not an int. It's not a Python int, at least. It's a Z3 int.
How do you unwrap it?
Yeah, so you unwrap it via this as long thing. There's some simple as long thing, and then you can sorry about that. So you can check the type of this. This is an int. That's all good. So that's how you unwrap it. Okay, so this is how you access the values of the models, but remember that your model may not have value for all of your variables, and a priori you have no way of knowing. I mean, over here you know that C won't be there because it's trivial elimination, but in more complicated situations, Z3 can do really clever eliminations, and you have no way of knowing what's in your model a priori, right? So there is basically 2 ways of doing this. One, you can use the in operator, right? You can use Python's in operator to scan whether a particular variable is in the model or not. But another way is to check what the return of this is, right? So remember, this model doesn't have any assignment for C. So if we do this, so let me just say z3.int C. So if we do this, we're trying to index the model with a variable that is not inside of the model, right? So in this case, the model will, the indexing will return none. And this is a Python none, right? So you can use this to sort of detect whether some variable is defined in your model or not. Okay. So yeah, so this is, so of course, if you don't do this check in your code, then you might end up calling .as long or none, and sort of all sort of bad things might happen. Right. So final thing about models, and then it's all just push and pop, and I'm going to go over these. It's just things that you've probably seen, and it's fine. Okay, so final thing is this model has got a really nice function called .evaluate. Here you can pass any Z3 expression, and it will evaluate that Z3 expression inside the model. And it's got a really nice flag called model completion. If you set that to true, it will automatically arbitrarily choose some value of all the eliminated variables, right? So for example, over here, so just remember Z is basically Z3.int C. So I'm evaluating this expression, we just say C inside of our model M, and I'm setting model completion to true. So let's just comment out this guy. So if you do this, you guys are still here in the meeting, right?
Yeah.
Yep.
So if you do this
for maybe a couple of more minutes.
Yeah. So if we do this, like it's just going to tell you that it's just going to choose a particular value for your C, right? I'm just printing out C and the type of C, right? It just decides to choose the value. Arbitrarily picks a value for C. Because C was not there in a model, any value is like still a valid model. So you can just add in whatever value for it, and this will automatically do that for you. And you can also use evaluate to directly evaluate the value of an expression. Of course, that will give you an integer expression, and so you have to sort of then unwrap it again. But like that we have already seen. Yeah, so you can evaluate Z plus X as well. So this is going to be some, I think, A plus C that is evaluating here. Okay. So this is basically all I had. There is some more files over here that will upload. Specifically, I've converted this mod to counter to this thing as well. So you can take a look at that. If there's no more other questions, I think then I need to stop right now. So is there any questions?
No, sounds good from my side.
Okay, sure. So, all right. Anyone else any questions, or should I stop share and stop meeting and wrap this up? I'll take this as a no questions thing.
So yeah.
Oh, so there was some. Okay. All right. So yeah. Bye.